Good morning, everyone. We will start panel 3 now. So I invite you to take your chair here. Good morning in Calgary, and people online, good afternoon east of Manitoba. So we're glad to have a countrywide broadcast today, and we look forward to speaking about our accomplishments, achievements. So in panel 1, you heard about this Canada-wide collaboration by organization dedicated to research and commercialization. Panel 2 is kind of a deep dive in some science, but panel 3 is where the so-called rubber hits the road, commercializing these technologies, finding customers, and having real-world deployment in a sustainable and economic way. So I'm pleased to have my panelists here, and we will get going. So one more point of logistics is we will have time for questions. So on the people here in person at the Energy Transition Center, when at the end of the panel here, I will invite you to raise your hand if you have questions. We'll bring a microphone to you so people online can hear your question. And people online, please use the question or the chat function to ask your question, and somebody here from the AV staff will read out the question for us. So yeah, so I see a clock there. That's just the time, right? So it's not that I have 19 minutes left. So okay, so I will first have a round of introduction, and I'll start over with Eva, and then Steve, Jessica, and Dick. So initial introduction: who are you? Why are you in this climate change business? And what does your company does? And then we'll dig deeper in another round about how does it really works. You got to turn it on.
I'll try to keep it very brief. I'm Yves Champagne, co-founder and chief carbon officer at Carbon AI, proud Calgary-based company. So what do we do? So our company focuses on helping create the highest quality environmental commodities possible. We'll get into it a bit later in terms of why that's really important, but our focus is really on when reductions are created, reductions and or removals are created, how do you ensure that those emission reductions or removals are real? And so through our technology and platform, we're able to do that. I think why I'm here, I've been in this space for a long time. I spent over 12 years in the project development space in this industry across many different project types, including methane mitigation. And methane mitigation for us as a company has been exceptionally important for a few key reasons, but the biggest being our view is that the challenge of climate change is really fundamentally a math problem. Our emissions are here, we have to get to here, and how you get there is through subtraction. How do you reduce emissions? And so I think a key part of what we've been doing is try to quantify. It's so important to us is that methane has a high GWP value, a greenhouse warming potential value. So if you're trying to get the most reductions possible at the lowest possible cost, methane is an exceptionally efficient molecule to do that. So we'll give a few examples as we get. That's a bit on me.
Okay, my name is Steve. I'm the founder of a company, Calgary-based company called SensorUp, and we help some of the world's largest oil and gas companies to run their methane emissions reduction operation. So we are a software to really optimize the operation to reduce methane emissions as well as carbon accounting. So we also not only for methane emissions reduction, but also for direct air capture, for example. And we'll share more stories, use cases later.
Hello, everyone. My name is Jessica Schumlich. I'm the co-founder and chief operating officer for Howard Emissions Management, also a proud Calgary-based company. And our mission is to help oil and gas companies understand where their emissions are coming from and track and prove performance. So we do so by software and consulting services that basically does the most complicated data stitching exercise ever. So taking traditionally reported bottom-up inventory information as well as other types of data such as satellites, drones, planes, continuous sensors, brings all the data together to come up with a measurement-informed inventory so companies understand where their emissions are coming from so they can really target the best possible capital projects to reduce their emissions.
I'm Dick Brown. I'm a founder, CEO of Cathero Solutions, Inc. Some of you might have heard Mitch yesterday coming and speaking to you. We are a methane mitigation company that removes methane emissions from pneumatic devices. And so why that's important is because 40% in Canada of the emissions from the energy industry come from pneumatic devices. In the US, it's as high as 69%. The estimates come from pneumatic devices. So we have a solution that very quickly, easily, and cheaply deals with the methane emissions. And so we are a classic case of how PTAC and CRIN and other organizations in Canada can help launch a local Calgary company into an international stage.
Thank you, everyone. So let's launch into how do we get real emission reductions from your products and services? And we'll start with Dick here. You're the only hard tech company here, right? So it's quite easier for you to explain without giving a chemistry course or mechanical engineering course. How do you go from the pots and pans you have with less methane emissions in the air?
Okay. Yeah, we're hardware as a service company, but all our coders would start to argue that we're almost software as a service as well. But what we do basically is we use cryogenic nitrogen. So air is separated, nitrogen is turned into a liquid. We buy it from the many air separation units across North America. And then we put it into small cryogenic containers on lease. So if you think about like a propane tank, it's very similar, only smaller. And then the liquid nitrogen replaces the methane that was historically used to actuate pneumatic devices. And so now, when a pneumatic device vents, like it has for the last 150 years, it vents nitrogen, air back into the environment. And then what we do is we have a very broad-based distribution network now across North America that on an ongoing basis fills these tanks up once a month. And we have continuous monitoring of the tanks, so we know what's going on from the operations of the control systems on site. And we report that data back into whether it's for verification for carbon credits in Canada or for the information basis of the large companies that we deal with.
So in summary, you supply like 1 ton of nitrogen to the site, and that removes 1 ton of methane into the air. Is that, or it's more complicated?
When you think of cryogenics, a liquid form, we take a liquid in liquid basis, it expands 700 times into a gas. And so we know that when we turn that into a gas, for every standard cubic meter of methane that was being vented, we use 1.274 standard cubic meters of nitrogen.
Okay, there's some engineering calculations involved.
Well, I'm an
Okay.
engineer, so
Okay, well, it's
hard to escape.
okay. Next to Jessica. Now, software. How's the software actually reduces emissions?
Yeah, absolutely. So recently, we have come to realize that the oil and gas industry is not necessarily reporting the greenhouse gas emissions accurately. sometimes higher, sometimes lower, and that's not nefarious whatsoever. That's just because of the current regulatory frameworks that exist that sort of say this is how you report emissions. What we've learned is that methane emissions are actually really difficult to track. And the reason why is because asset bases are really distributed. They vary in temporal and spatial. And so it's really difficult to understand what that is. And so what we do is try to understand where those emissions are actually coming from a measurement informed basis. And so, for example, if you have a piece of equipment, let's say a compressor, we might have traditionally reported emissions factors from 20, 30 years ago. And we actually realized that those emissions are maybe more than we had originally estimated. Now, when you go and do a capital project saying, okay, I want to do some sort of replacement of my compressor, you can then, with a measurement informed view, say, hey, actually, my amount of emissions that I'm going to reduce from this compressor replacement or whatever it is double what I thought it was. And so therefore being more effective in actually targeting where your emissions are coming from. Additionally, and I'm sure we'll get into this, but we're starting to work a lot with different global forces that are demanding greenhouse gas emissions to be measured and reported. So we've seen the Asian and European markets, particular in Asia, Singapore and Japan, Korea, and then all over Europe really require you to accurately report your emissions. So we're helping upstream operators mostly do just that.
So is it fair to say the software gives the operator the tools or the intelligent tools to actually do the emissions reduction?
Yes.
Perfect. Another, sensor up, you don't make sensors, right?
No, the founder's a stupid idiot, make a name sensor up, but doesn't sell sensors. I'm the founder, yeah.
So tell us about your software and same question. How does it actually
Sure.
result in real emissions reduction?
Thank you. So our software is really laser focused on operations, right? But the how is by combining sensor information from the space to the ground to operating system to the humans on the ground. We have the visibility about what's going on. So the operations can know the predictions like, okay, what's going to happen? And the most importantly is the operational execution. In the past, we did this for homeland security, military, but we found out, hey, methane emissions reduction is an operational problem. And how can we, our reduction pathway is find it very, very quickly and fix it quickly so that they can reduce tangible reduction. And that's how we do with some use cases. For example, one customer recently sent out a case story. So they have some sensor, two kind of sensor, found out some intermittent, emissions. It's like, oh, what's going on, right? And they attribute to different things. And they sent a team over there, found nothing, and sent a team a week later, and they found out actually there is a relief valve. They relief have emissions every 5 to 8 minutes for 3 seconds. Right, that's why the first time I didn't see it. And then, but still don't know where's the problem. And the next trip, they found out, hey, that's a dump valve is leaking. And they fix it. It took them 2 weeks. It's before sensor up. After sensor up, they can go just find all the data together, then find out in minutes, and then fix it right away. So that's, we not only save their operational costs, but also save their emissions.
So you bring together like hundreds of thousands of
Yes.
sensors together. So you're like the Google of methane reduction.
Context is the king. We provide the context in space and time.
Okay, perfect.
Sure.
So Ivan, same software, but onto the financing side, right? In terms of
I think the value proposition, you want me to transition? to
yeah,
value?
no. How does your work, your services reduce emissions?
Okay.
And
Hold it higher. Got it. This better? Okay. Sorry about that. So environmental commodities are not like physical commodities. So if we have people in the audience who are in the mining sector, for example, if you are sending a shipment of iron ore, you have physical delivery of that commodity at the end of the chain. But with environmental commodities, they're synthetic, meaning They're not physical. And so what that means is the value of that commodity is based on the underlying data. And if your data is poor, you have a commodity that is either has little or low value. In many cases, you can't actually transact. So if the data is poor, your environmental commodity or what the result is also poor. And that translates into economic value. So what we do is help ensure that if you're trying to make a claim on an emission reduction, that you can prove it. And so the challenge around methane is that methane is both a big problem and small problem, meaning there are very large sources of methane emissions across the world. A great example of that would be large flares in the oil and gas sector. We don't see that a lot in Canada, but in places like Africa, the Middle East, Southeast Asia, they're ubiquitous. They're everywhere. So you can have a flare that is 20 million standard cubic feet or scuffs in size. That is just as much production from one source as many oil and gas producers produce on a daily basis. It's the same, just to give you a sense of the size. But methane is also a small problem where you have these various pieces of equipment. Our friends from Cathyros have talked about pneumatic devices, right? One pneumatic device can emit 60 to 120 tons CO2e per year of emissions. It's small, but when you have millions of them across the world, it adds up to a big number. So what we help do, and our solution, is provide integrity across the entire chain from source point to end commodity to ensure that that data trail is immutable, meaning no one has tampered with it, that the data supporting it is real, so that you can prove that your outcome is actually real. And that means that someone is willing to buy it. And hopefully someone is able to buy it at a premium price. And just to put this in context, in the voluntary markets internationally, a low-grade credit might be worth $1, $2, $3 per ton. That same credit, if it is deemed of high integrity or high quality, could sell for over $30 per ton. In certain things like carbon dioxide removals or CDR, those credits could be worth hundreds of dollars per ton. So there's a big, massive value proposition of ensuring that the emission reductions that you're creating are in fact real.
And we'll stay with you, Yvonne. So the title of the panel is Reaching Out. So in Canada, you mentioned we don't have big flares and we've done a good job. The provincial agencies report 50% plus in methane emission reductions. How about the international market? And have you been to Africa? Have you been to Middle East? And are they receptive? And is there traction for this?
Yeah, yes and no. So, the great thing that we like to think about methane is, as I said earlier, if you view climate change as a math problem, methane is an exceptionally efficient way of getting a lot of reductions at the lowest possible cost. And so for that reason, you can get a much bigger bang for your buck by tackling one flare, for instance, as opposed to a CO2 reduction project. I would say that in the voluntary markets, specifically as it pertains to methane mitigation in the oil and gas sector, it is not necessarily a popular project type. It's not what they would say in the industry parlance. It's not charismatic. It's not like a nature-based project.
Not like planting trees.
Exactly. It just not seem to be as sexy, right? We believe, though, again, with our frame that climate change is a math problem, that projects that are metered, that have good data, that you can prove that these emission reductions are real, that's what should be sexy. And so we're trying, through our platform, to help make these projects fare better, not only in compliance markets where people care less about the sexiness factor, but also in voluntary markets. You should want, if you really care about climate change, you should want methane mitigation. And one of the best places to get a large quantity of methane mitigation is in the oil and gas sector. So you should be a part of it. So in some of the areas that we work in Africa, Southeast Asia, across a variety of different project types, stakeholders want to get these projects done. There's huge co-benefits associated with flare gas mitigation, for example, huge impacts on health, downwind. You're conserving a resource that can then be sold. So there's an economic values. So yeah, hopefully that.
Perfect. And Steve, so you're not just operating in Canada. where else in the United States? And talk to us about your successes in outside of Canada.
Yeah. So when we talk to producers, right, do you want to run your operation better, cheaper, and then reduce emissions? They say yes, right? Because and safety is very important. So actually, we are laser focused on operations, and we have customers in Europe, in South America, in North America, States, and Canada. So I think the value proposition we offer is run your operations cheaper and better, and then safer, and that's really resonate with them. And then so you know what? When we get help you to do this, aggregate different sensors, you know what? The data are better and it feed into our partners for reporting or in the monetary side, and it just naturally have a better reporting and more accurate measurement.
So you're an example of having done it here. You can export it to the countries you mentioned, and it works there as well.
Actually, yes, we done it here. Our first customer is in TC Energy here, and then yes, and then we start to export to the worldwide, and then yeah, but US really move faster than here.
Oh, they move faster. Okay, very good. Still, in 2025, they do, right? Yes. Okay. And
Yes.
Jessica, same. Last time I talked to your co-founder, he was in Paris. So
Yeah.
talk to us about the European Union.
Yeah, absolutely. Yeah, I want to reiterate that point that Steve just made, though. In terms of the U.S., we've actually seen a lot more adoption in the U.S. We have over 50 customers, and the majority of them are U.S. based or European based. So I think that says something. Also, Canada, get on it. It's time. Let's go. Yeah, European Union is a really interesting market right now because the European Commission has said that any gas or oil crude products, but let's go with gas because LNG markets from Canada and the US are most important here, will require a greenhouse gas or methane reporting that is measurement informed starting in 2027. So the regs are already published, and now there's just some semantics in terms of how, when, exactly what it is. But in essence, any operator that is planning to or currently does go into the European Union will require from the origin of the gas to develop out a measurement informed inventory that's auditable. So that means how does that actually go from the importer all the way traced back through the supply chain to the producer? And yes, we don't have any LNG exports terminals on the East Coast currently, but a lot of our natural gas does end up in Gulf of Mexico, which eventually ends up in the European Union. So it is a problem for Canadian-based operators as well.
Yeah, and talk to us about the European Union is based on OGMP 2.0, and that's the United Nations. And on the Pacific side, and Japan, South Korea, they are going there as well.
Yeah, absolutely. Yeah, Oil and Gas Methane Partnership 2.0. It's a United Nations led initiative. There's about over 150 signatories representing over 40% of the global supply chain. Japan reported last year that I think it was like over, don't quote me on the numbers, but 90-ish percentage of the gas that was actually imported into Japan was OGMP. So basically, what is OGMP? It's a framework that is sort of not tailored approach, but tiered approach, where the year that you commit, you just have to report, and then it gets sort of more stringent and stringent as time goes on. But we are seeing the biggest global markets, European Union, for example, which imports 60% of their gas is actually of their LNG, sorry, rather is from US, really move in the direction of measurement informed inventories. And the European Commission, the reason why we were in Paris was we were working with IGOP to develop out the measurement, reporting, and verification standards that are going to be critical to prove the sort of supply chain. Yeah.
Awesome. And Dick, you operate in the Montney, but also in the U.S. Talk to us about U.S.
Okay, but
Well-
first, I think,
Yeah, you're on.
don't we work with you on OGMP 2.0, or we did? Because we're now approved in OGMP 2.0 for our data, but you'd know more about it than I do.
We have a joint project where we're developing source-specific emissions factors using Kathairos data. Yeah.
That's good to know. So international markets. So the sentiment here, which you've heard, is Canada moves slowly, US moves fast, and we certainly experienced that. Just give you a very quick timeline of our company because we're very new. In 2020, came up with the idea. 2021, PTAC helped support us in our first piloting. At the end of 2021, we were invited through the Canadian Trade Commission to present our technology at a Colorado Clean Industries Association Oil and Gas Clean Tech Challenge. So it's like 100 different companies participated, but we were the ones that won it. So even though we were born in Canada and our first customers on paper came through CRIN with both Synovus and Ovintiv, because of our exposure in the US, Exxon grabbed hold of it and then took us to scale very quickly. In Canada at the same time, Ovintiv was doing the same. So now from 2022, those first trials, 2023, we became first commercial, got our first trucks distributing nitrogen. We're now on 2,800 locations with 70 of the biggest oil and gas companies in North America. I would say 85% of that came through our expansions throughout the US. The Canadian Trade Commission is now taking us or supporting us into the Middle East, as well as Argentina, and we're looking at a few other countries because the technology is so simple and easy to deploy.
There's nitrogen everywhere.
Yeah, every time you breathe. Yeah, so it's a pretty simple process that has applicability across the world.
Perfect. So now we'll turn it over to questions. If people here have questions or you've seen questions online, otherwise we will keep going. Okay, Lisa. No, just wait for the microphone so you can people online can hear. We can hear you fine, but there's people in the.
So I feel like I got to ask the obvious question. You all said that Canada's slow and the US is fast. What can we do to fix that? What's the one thing we can do tomorrow to fix that? It seems like a big gap.
So I want to give Canada and Canada Innovation a ton of credit here. It's actually really funny. I know all of these gentlemen very well, and we tend to end up in the same conferences. There's a lot of Canadian talent that is international, and we have a really good innovation network from sort of the beginning, from the early stages. We through CRIN, through PTAC, through ERA, through NRCan, through AI, Alberta Innovates, have gotten a ton of funding to support our development of our technology. Amazing. Where we have struggled more in Canada is the actual adoption of the technology from the operators. And so either less of a risk tolerance from Canadian operators, or maybe potentially more funding in that side of things. The US operators really saw us as a value add, being the first adopters, whereas Canada was or is maybe a little bit slower to adopt the technology and wanted to see major proof points before actual adoption. So
yeah, I certainly have some opinions about that. First of all, the adoption in the US is rampant for us. It's hyperscale. And I would say most of the technologies that are deploying in the US came out of Canada. Certainly, there was more certainty in the US when we first introduced ourselves, and that's changed a lot. But the operators there are looking right through the current administration and behaving as if this is something they just have to do, and they want to do. In Canada, I think the operators also want to do it and know they have to do it, but there's been a ton of uncertainty, which I think maybe even this week gets clarified. And then I think we'll see a lot more activity.
Well, hoping for Thursday.
Okay, so I want to build a large company, right? So in a way, my go-to market doesn't just include Canada. So US, the market is much, much bigger. So that's fine with me. Canada is slow. It's okay. And then, however, I think Canada is friendly for innovators. That's what I care. Because thanks to PTAC, to CREAM, to ERA, and this is awesome. And then, so in a way, maybe just us. But I think there are a few things we did right, which is, think about a lot of Canadian methane companies, right? Is the innovation start from here and then allow us to just export to the world. And then, of course, if the Canadian companies will move faster, it will be nice. But my market is not just Canada. I think nobody will just build something just for Canada, right?
Yeah, I will disagree a little bit, Lisa. I would say that Alberta specifically, I'll separate out Alberta from Canada. But up until very recently, Alberta has had the longest standing compliance carbon market in North America since 2007. And up until very recently, that market was also seen to be very investable, meaning the price signal in the market was deemed to be stable and relatively isolated or insulated, from political and policy uncertainty. And so people could invest off of that price signal. And that's why you have so many companies in Alberta that are specialists, not only in methane emission reductions, but in greenhouse gas reductions. And it's across the entire ecosystem. That market helped create a cluster, just like Bay Street is a cluster for mining, right? It's the exchange in Toronto has been very supportive of small junior scale mining companies, and that's created an entire industry around that. So Alberta has that, Calgary has that, but that's at risk today. So given what's been happening over the past year and a half, 2 years, that is going to challenge the foundation that supports that growth. So I would say we were early, but like any sector for Canada, we're a small domestic market. So once you get to a certain stage, you have to grow outside. And so for us, when we set up our company 4 years ago, we thought, where are we going to spend? Where do we have the ability to have the biggest impact possible? And so when it comes to methane, some of the largest sources of methane emissions are not here. They're elsewhere. And so we sought to go tackle those to help support the emission reductions on those types of activities, because that's where it is, right? Again, coming back to that frame of climate change is a math problem, you go where you have the biggest impact possible. So Canada, I would say, I would agree, from a federal level, it has been exceptionally slow. We'll see whether or not there's going to be some announcements here over the next couple of days to change that.
Any other questions? Yes.
Hi, my name is Paresh Tanawala, 2020 Environmental Solutions. I've been in the oil and gas for a number of years and helped a lot of clients reducing methane and flaring and everything. I guess my question would be maybe more towards you. When we reduce methane emissions through various techniques, how accurately can you quantify the actual net reduction? And will that be eligible for trading purposes, verifiable through ISO 14064-1, shall we say? I guess I wrestle with that question all the time and I don't have a clear answer.
Yeah, one of the reasons that we've, I guess, over time really migrated to focus or have methane be a primary focus of the use cases where our technology is used is I believe that you can create the highest quality emission reductions from methane mitigation because of the metering. I would argue that some of the metering, specifically in the oil and gas sector, there's high quality metering involved. You know exactly how much gas is moving from this place to the next place. And so because of that, you know exactly how much methane you're conserving. Again, that's usually in the case with those larger methane sources. When it comes to the smaller stuff, you can't meter everything, right? At a certain point, it's just not cost effective. And I think that's where, for us, I think there's been a bit of innovation in our company where We're able to timestamp, user authenticate, and geolocate data collection that you have to do manually. So if you don't have sensors out in the field to collect, if you have to go check a piece of equipment or ensure that a piece of equipment is in use or out of service, how do you do that? How do you prove that it's real? And so I think you can still get to the same place, even when you don't have metering, where you can still generate high quality emission reductions.
Yeah, I think you just described the business case for highway emissions management. In essence, you're right, you're never going to get the exact metering. The European Commission is the first jurisdiction globally that is requiring you to report your methane emissions from a measurement-informed basis. There are no ISO standards that currently exist. The European Commission is very aware of that and has commissioned IOGC, the International Oil Gas Commission, whatever the acronym is, to develop out those ISO standards for MRV, measurement, reporting, and verification. So we should see something in the public realm for comment, probably mid-2026, with the hope to publish for that 2027 timeline. So we are working on developing that so we can do so in an auditable, robust, and transparent way.
Interesting panel is we don't agree with each other. So I don't agree with you. Well, I mean, actually, the part is we believe in a sensor-rich world. So in the future, sensors will be everywhere. Actually, sensors are everywhere, and then they just do not talk to each other. So sensor up, yeah, sensor and up, and we started companies because we believe in the sensor-rich world future or now. And then when we say sensor, I mean sensors including humans. Right, we go there, we saw something, we record something. And when we put them all together, we have the much better picture. So I think the key is really get this sensor-rich world, the data together, so a better visibility. And then we can filter out the noises because not all sensor data are high quality and most of them are noises. But when we put all sensor together, right, redundant observation, improved accuracy, engineering, and then so that is the world we believe in. And then a measurement sensor-rich world, so we can find it early and fix it early, and we have meaningful reduction. It saves some money and make more money.
Other questions?
Can I just come back on that?
Okay.
So I want to make sure I can clarify. It's not that I don't believe in the value of sensors. It's that if something isn't measured, it can sometimes be used as an excuse to not act. And so while measurement is important, we believe measurement is only part of the solution. You need to actually mitigate or put in an action to prevent the emissions from happening. And some companies will say, well, I actually don't know how much I have there. So, until I have some better data, I'm just not going to do it. So for us, absolutely, we believe in sensors. We actually built a piece of hardware for a different use case in our technology, in our company for clean cooking, to actually meter cook stove usage. We didn't feel that the hardware, the sensors in the industry were good enough. And so we used our knowledge developed in the oil and gas sector to actually build a meter that we felt was better to actually collect that data. So it's not to say that it's not important. It's that in some cases, it's used as a reason not to act if there isn't measurement. And so we always defer to action over just measurement.
Perfect. Okay. Other questions? Yes, Frederick.
Thank you very much. My name is Frederick. I'm a student at U of C. So my question is, what are the biggest barriers to methane emissions reductions and how can we overcome them?
All right. Very broad question. Anybody wants to go ahead? Me? Oh, I thought you wanted my
No, I'm like,
but you're at U of C, so
sure. What's the
well, he is an entrepreneur, but he's also a professor, right?
Yes, I'm Professor Yu. So, was it other problems? But I think the biggest problem, it's getting better now, is to recognize it's a problem, right? And then, but how urgent is that problem? So I think all of us, including the problem owners and us innovators, we need to really build more, what can I say, ROI use cases, right? To say, hey, this is not good for the environment, but also good for you. And these are the why, right? I think that's very, very important, which is, okay, this really make sense. It save you money and make you money, right? I think when we have more of these successful stories, and things will be better. For example, our customer Oxy, they said Sensor Up reduced their 35% of the truck rolls. They're like, oh, nice. And with many other stories, it's about, okay, turn this from days of emissions into minutes to hours. And those, when you have more and more of those stories, and it become more like, hey, yeah, why are we doing this, right? And we need more of these stories, and you need to be, all together to build those successful stories. Hopefully, they are Calgary-made solutions, right?
Yeah, I couldn't agree more. We often talk to our customers about turning it in from a cost center to a profit center. And so really understanding the operational relationship between emissions reductions. We've moved away from using the word ESG. That's almost a bad word, especially in the States right now. But if we can tie it to operational efficiency, keeping gas in the pipe, and really build those ROIs, we're going to see more reductions.
So your question is basically, why aren't we growing faster? And as a service that mitigates methane. First of all, our growth has been hyper. So there's not a lot of barriers that we see. Very quickly, we became the biggest methane mitigator in the oil patch from pneumatic devices in very short order. But anything that's caused a change in our rate of growth has been political. So it becomes a question of certainty with the energy industry. The one thing the energy industry hates is uncertainty. And so with all these changing regulatory views and all the discussion in the public, that I think has caused people to wait just to see what's going to happen.
For sure. So I want to thank the panel. So I think come back to maybe that question is all of my panelists here. Your company did not exist like maybe 10 years ago, right? It's just to speak to the rate of growth. Like in five or 10 years ago, these were ideas, and today you're talking about thousands of tons of reductions and tens or 50 amount of employees and many customers in many jurisdictions. So the rate of growth has been there. It can still double, right? Or triple. So because we're just starting. So thank you, everyone. Thank you to panelists. And thank you all here in the audience for listening to us, asking insightful questions. Thank you for people online. And thank you for ETC Foundation, CRIN, and Climate Week Exchange for hosting us. So we'll be around here for a few more minutes as we wrap it up. So you can come up and ask if you still have questions to our distinguished panelists, and we'll see you around. Thank you very much.